So in this video, we're going to talk about how to use quadratic functions to model data in Desmos. But sometimes your data may have a curved pattern. So in that case, you have to use a quadratic regression to write an equation that best models the data. So in this video, we're going to talk about how to do that in Desmos. So remember, you're going to click the plus sign in the upper left-hand corner and then choose the option that says Table. And then once your table shows up, you're going to enter these values from your problem into the table. So we enter 0, 10, and then Desmos will usually try to predict based on the pattern. So if those are correct, you can just click enter. If not, you can just overwrite them. And then for Y, we have 489, 801, 1202, 1998, and 2959. So now we're going to go down here and tell Desmos that we need a quadratic. So the way we tell Desmos that we need a quadratic is we entered standard form of the equation here. So we have y1 is approximately ax1 squared, and then plus bx1 plus c. Okay, make sure that your equation looks right and that nothing wound up in the wrong place. Now it gives us the values of a, b, and c that we need to write our quadratic equation. So we can plug in this value 1.21 for a, and then we have 1.21x squared. B is about 13, so we have 13x, and then c is about 504.26, so that's what's in our equation. So let's try this example. It says the equation y equals negative 0.0002x squared plus 0.0334x minus 0.5033 models the average number of automobiles per licensed driver from 1950 to 2010, where x is the number of years since 1900. Use the equation to estimate the number of automobiles per licensed driver in 1987. Well, it's very important to note that x is the number of years since 1900. So if we're talking about 1987, we're going to say, well, 1987 is how many years since 1900? Well, that's going to be 87 years. So that's going to be our value of x. So we just go to this equation and plug in x equals 87. So we have negative 0.0002 times 87 squared plus 0.0334 times 87, and then minus 0.5033. So we're just going to do this all in our calculator, right? Because it's just a bunch of number crunching at this point. So we have negative 0.0002 times 87 squared minus, plus 0.0334 times 87. And then we have minus 0.5033. And then when we hit enter, it gives us y equals 0.8887. Okay, which approximately equals 0.9. So we have about 0.9 automobiles per driver in 1987. So a little bit less than 1. So now let's try this problem. It says determine the equation of the quadratic regression curve. Use the equation to estimate how long it would take a single person to complete the project. So we have the number of team members, which gives us an x value, and the time to complete the project, which is the value of y. So I'm going to clear everything out in Desmos and then start all over with a table so I can enter this into my calculator. So I'm going to pause the video while you go ahead and enter these values into x and then enter row 2 into y. So now you can see I have all these values entered, so I'm going to tell it to approximate a quadratic. So I'm going to type y1 is approximately ax1 squared and then plus bx1 plus c. Okay, so down here in parameters, it gives me the values I need to write my equation. So I have y equals 0.12x squared minus 3.46x and then plus 28.34. So it says how long would it take a single person to complete the project? So remember, a single person is going to be x equals 1. So we have y equals 0.12 times 1 squared minus 3.46 times 1 plus 28.34. Okay, so we're going to go now to our calculator. And so we're going to do 0.12 times 1 squared, and then minus 3.46 times 1, and then plus 28.34. And then when we hit enter, it tells us about 25. So it's going to take one person about 25 hours to complete this project.